Hi, I wanted to talk today about discovering distant relationships through STRs. Um, STRs, as I've said in the previous tutorial, there's two kinds of Y-DNA that we use for genetic genealogy, the SNPs and the STRs. SNPs are more reliable. Um, they don't generally mutate over one another in the same place to obscure what the allele of the ancestor was in the way that STRs do. Uh, STRs still can be useful for finding distant relatives uh, if you're lucky. If you know how to look at, if you know how to visualize the rarity of shared alleles that you have with other men, and if you share a rare allele with men that you're related to from a common ancestor. So let's jump into an example. Um, I've loaded the STRs of a Jewish lineage of my that's relatively closely related to my male line. I'm J2B L283. This exclusively Jewish cluster of guys have very telltale STR signature that shows their common descent. DYS 385 1217. Every single one of these guys has it except this one guy. He just mutated it after having this common 1217. Why is 1217 showing up red? It's because uh, I've given a genetic distance cutoff to limit the results of the guy that I searched on. And within the genetic distance cutoff, the vast majority of the guys do not have 1217 for this allele. This shade of red corresponds to here 4 to 8% of the matches that you see have this shade of red. Um, so it's rare. And this other allele, DYS 447, is 25. That's also pretty rare. It's not quite as rare as this other allele, but it's rare enough that you can figure out their common ancestor had this DYS 447 is 25 because every single one of them has it except for just a few. Interesting thing about this Jewish lineage. Um, look at some of these guys. Lithuania. Uh, we hardly have anybody in JL 283 that's from Lithuania. This is just kind of showing you the geography of a lot of European Jewish lineages. They end up going to Lithuania, some of them. Um, and then look down here. This guy's from Lithuania too. His genetic distance, if you just add up all of the differences on all of the STRs, his genetic distance is 13. There's other guys that are slightly more close by genetic distance. Um, this guy from Bulgaria, but his haplogroup, I know he's not actually closely related to these guys. This is a different lineage of JL283 that is not Z1043. Just by chance, his STRs happen to be somewhat close to what these guys have, relatively speaking. Um, so that's why genetic distance by itself is not an adequate measurement, not an adequate metric to figure out who is really your closer relative. You should look at genetic distance and shared rare alleles. Because if somebody really is your closer relative, you should have some of the same rare alleles that they have that you inherited from a common ancestor. Um, oh yeah, so what I wanted to say here, so the first thing I mentioned was this group of all Jewish guys descending. So they just, DNA doesn't know what language you speak or what religion you are. It doesn't pre-program any of this, in my opinion. It's not scientific opinion uh, to believe that. Um, but the proof is in the pudding. These guys who are all Jewish today, or they have a history of Jewish tradition in their male line ancestors, by genetics, they also all descend from the same guy. So in the case like this, it's pretty cool that you can know their most recent common male line ancestor had to have been Jewish, because what's the chances that every single one of his descendants are Jewish today or have a history of Judaism in their male line? So it's really cool that we can it, it it it's cool anything that we can learn whatsoever about our really distant relatives. And this line in particular is very old. Um, I think it's over 1,500 years is when their most recent common ancestor lived, of all the guys. So anyway, most of the guys in this lineage are really distantly related to one another, but some of them are more closely related to each other than others. Of course, it's like a tree. There's branches within this Jewish lineage of Z1043. One of the branches you're looking at right here, this visualization, STR Match Finder, shows you these two red alleles here, DYS 48715. It's rare. I'm going to scroll down. You see, look, like almost nobody else has this. These other guys are just really distantly related, and they by chance have the same rare allele. So on the basis of having DYS 487 is 15, rare mutation, you could practically assume, though it would be prudent to test it, confirm it by a SNP test, uh, that these two guys that have this rare allele and also are close genetic distance matches, relatively close, their genetic distance to one another is 3. And they only differ from one another on the most unstable alleles. Okay, this is what you would expect for people that actually are each other's closest male line relatives. Because they share, the alleles, I'm sorry, this STRs are ordered here from left to right. On the left are the most stable. That means their mutation rate is lower. So the fact that they both have this relatively conservative STR mutate to the same value, like it could have mutated up from 14 to 15, or it could have mutated down from 14 to 13. Both of these guys mutated from 14 to 15. You can practically assume that they are each other's closest male line relatives. And I just contacted them today to let them know that that this is my prediction. When I started out as a haplogroup administrator, I didn't know about the the mutation rates of the different STRs. To me, it was just, well, I'm just going to look at the genetic distances of who comes up as matches from a family tree DNA's matches, STR matches, and if someone is a much lower genetic distance, I would tell people, hey, this guy is your closer relative. That's that's still generally true, but there's so much more rich, detailed information in the exact alleles of people of their STRs that allows you to create a more reliable uh, tree structure showing the relationships of the individual people based on shared rare alleles. So, what can we practically gain from having identified a an allele that may that looks like it indicates its own branch of this this lineage JZ39653? What's the point? Well, you can create a tree structure like this. The family tree DNA and YFL make their tree based on people that do next generation SNP tests because the SNPs are the most reliable. They make a tree mostly based on SNPs, although YFL does sometimes use stable STRs. Uh, you can, because you're a researcher and you have access to all the STRs of all the people that are closely related to you, you can do the same kind of thing. You can take this SNP-based tree structure that already exists and lay on top of it additional phylogeny. Phylogeny is just a term that means more branches or just branches, having children and children and children, having a known tree structure. So you can add more detail, you can add more branches onto this tree if you can figure out which rare STRs are shared by the various members of whatever lineage you're looking at. And you just need to always keep in mind these are STRs. This tree that you're creating now is based on STRs. It's not as reliable as a SNP based tree, and so you should really verify these predictions by testing these guys, doing a next generation test like a WGS or a big Y, and test these guys to see, do they really, these guys, this Russian and Netherlands guy that have DYS 48715 that none of the other guys had, if this was really indicative of more recent common descent of these two guys, as is shown in this tree that I just drew, then they should have some SNPs in common that the other guys don't have. And then you would know, yeah, it's definitely true, this prediction that you made. Just something interesting from a historical perspective. I mentioned this was a Jewish line, male line. The guy from the Netherlands indicated his ancestor was living in the Netherlands since 1700s, and the guy from Russia goes back to 1850s. Um, when I was in Amsterdam, I went to the Jewish Museum. I think that's what it's called, but it's inside of a synagogue, and I learned that the Netherlands was a very when they got their independence from the Spanish in this I think 1600s or maybe it was 1500s. They were really religiously tolerant relative to other places. They really wanted to just make a lot of money, and they didn't care about if someone was a different religion as much. Um, or maybe it was also because the experience they had with being ruled by Catholic Spain that they wanted to have a more religiously free society. So anyway, some Jewish people that were experiencing violence in other parts of Europe started to move there, and I read in the just in the Wikipedia article. I don't have access to a lot of books because I'm living in Georgia and they don't have very many English language books. Um, Oh, so on the Wikipedia article for Jews in the Netherlands, I read that there was something called the Khmelnytsky uprising that happened in the 1600s that in eastern Poland that a lot of Jews decided to leave the area because of this. This and some of the ones that came to the Netherlands um, were fleeing this event, and I read that a lot of them tried to come to Amsterdam, but the authorities didn't want to let them in because it was too many refugees, and so they just lived in villages in the countryside. Um, and so I just mentioned that to these people that it would be really interesting if we can figure out where was your most recent common ancestor living? Was he actually living in Eastern Europe? And is this uh, so? This is how you can try to piece together. So if that turned out to be true, that if that turned out that that was how their ancestor migrated to the Netherlands, then we've just figured out that this branching point here, the ancestor at that point probably lived in Eastern Europe, uh, and you just keep doing this, and you can piecewise get an idea further back in time where was the common ancestor of the or even earlier branches living. It's just you just got to keep doing this work. So I think that's enough for our introduction to using STRs to find uh, potentially distant relative on the basis of rare shared alleles. Uh, but I want to mention some lineages, some haplogroups, there will be more noise than others. Meaning, in some haplogroups, if you have a lot of distantly related men, but not so distantly related that their STRs aren't anywhere near yours. But if you have enough guys that are a few thousand years distantly related to you, and there's a lot of them, then you're going to have a lot of noise, meaning some guys may have the same STRs as you, uh, and it's not going to be indicative of being closely of them being your one of your relatively closer relatives. Uh, each lineage, each haplogroup is going to be affected to this be affected by this to a different extent. Some haplogroups in R1b, I've been told that people have exact 111 STR matches, and they're not even related within 2,000 years. Now, I have not experienced this myself because I don't. My haplogroup's not like that, and I haven't found that myself when I've helped other people who are some lineages of R1b. But if that's true, then STR Match Finder isn't going to help you because it's just going to show a ton of people that have the exact same STRs as you. And if in the 111 STRs there's no differences, then that's not going to help. That being said, I have been able to help people who are various branches of R1b to find relatively relatively closer relatives using STR Match Finder. Uh, and in my own personal case, I'm J2B, L283, but my mom's male line and my mom's mom's male line are both coincidentally R1b, U106, L48, which is common in England and in Germany and in some neighboring areas. Coincidentally, they're both the same. One's from Germany or formerly Germany, Poland, um, and one of them's from England. And but they're both L48, R1b L48. And I tested Alpha beta, which is 37, equivalent to family tree DNA is 37 STRs. It's actually a lower number of STRs. I mean, family tree DNA says it's 37 STRs, but it counts the palindromes multiple times. Like DYS 464 is actually one STR that has multiple values, multiple integers, because it's a palindrome. Anyway, that's a technical detail that you don't really, well, it's good to know. Um, so anyway, when I tested my grandmother's male line relative from near uh, Gliwice, Poland, and I mean his male line origin, as far as we can go, is from somewhere near Gliwice, Poland, in Silesia. Uh, his alpha beta results, I used that to try to narrow down testing SNP by SNP, seeing which guys he matched and what haplogroups they are. Uh, it was not easy at all using STR Match Finder because of the noise of many guys who are R1b U106. Um, so maybe if he did 111 STRs, maybe it would be easier to see which guys might be his closer relatives than others. But at the alpha beta STRs, it wasn't clear. But I still for the most part made accurate predictions, but it wasn't easy to do. Um, for L283, J2B L283, I've made all of the progress I've made in finding distantly related men who they didn't have any STR matches, or they with I mean within the FTDNA matching system, it said, yeah, your uncle is your relative, and these guys that have the same surname as you and maybe 100 years distant, yeah, they're your relatives too. Of course, as a haplogroup researcher, uh, that's that's not the most interesting thing for us. We want to bridge the distant gaps. We want to see this surname clan from this area, who's their next closest related surname clan, and from what area are they from. That's how we figure out where our ancestors have been living in the more distant past. So to figure this out, the FTDNA matching system isn't useful. It doesn't show you anybody that's related that distantly, and it doesn't show you the rarity of the different shared alleles that you have with somebody else. So I'm not an administrator anymore at Family Tree DNA, and I still make progress in research of my haplogroup because you don't see any really haplogroup research useful matches from FTDNA's matching system. So I use the STR Match Finder because of the visual um, easy way that it indicates shared rare alleles that are usually indicative of common descent. In a future tutorial, I will show some examples that illustrate the power of rare STR allele signatures, where I was able to correctly predict men that were several thousand years distantly related to one another, but were each other's closest male line relatives relative to other men in the project. And I made a specific haplogroup prediction for them because they matched the STR rare allele signature. Um, and I'm going to show some examples where my predictions were incorrect, and just give you some advice on how you can avoid making the similar kind of mistakes that I've made in the past. Thank you. Just one last thing, in case anybody was looking at that tree, and I mentioned that these Jewish guys that ended up in the Netherlands may have come from Eastern eastern Poland because of the Khmelnytsky uprising. Actually, I just heard back from the relative of the tester, and she confirmed that actually that's not the case, and that the ancestor was living in Czech Republic before having come to the Netherlands. But before the Czech Republic, we don't know where he was living. I'm only mentioning this in case somebody in my haplogroup was looking at that and wanted to know actually where those guys came from. Thanks.